So we left off here last time. We wrote a very simple Hello World web application. Everything is built into one function, the main function, and all it does is it doesn't matter what page you go to, it just returns Hello World to the screen. So let's make this a little more useful, and we're going to do this really gradually. First of all, if you have the application running in your terminal window, you need to quit out of it. Control-C will stop it, and then I'll hide my terminal. And let's have a look at what we have here so far. Right now, we have the main function plus this handler function, which is built in. It has a built-in anonymous function within it that does everything we want it to do. So this works, but it might be a little more useful. Let's pretend we're building a website that consists of 2 pages. So we're going to have the home page. So I'm going to create a new function called func_home, and this is going to be a handler function. And this is something you need to remember. In order for a function to respond to a request from a web browser, it has to handle 2 parameters. A response writer, which I'm going to call W, http.responseWriter, and it has to handle a request, R http.request. And then, of course, it has to have the braces. So there's a function that will actually handle requests. Right now, it doesn't do anything, but it does, in fact, handle requests. And what I can do is, instead of this handler func with an embedded function, I can delete that entirely and say I'm going to make a http.handlefunc, and it's going to respond to the root level of my web application, in other words, the home page, and then it's going to call a function, home. Well, home is actually this function up here. And this doesn't do anything, but I can, of course, do my standard response and just say format fprintf, W for my response writer, and then just return this is the home page. And then I'm going to have a second function, and this is going to be an about page. So I'm just going to duplicate this line just to save copying and pasting. And I'm going to say for any request that comes to /about, I want to go to a function called about, which doesn't exist yet. But again, I can copy this, paste it here, change it to about. So now this is linked to this. And I'm going to say, instead of this is the home page, this is the about page. Well, this is cleaner. Now I have really short lines in my main function that point to external functions. But we can make it a little more complex than that. Instead of just saying this is the about page, let's have it return a computed function. So I'm going to have another function, func, and this doesn't actually have, it's not going to be a handler, it's just going to be a standard function that I can do anything with. And I'll call it add values. And this is going to take 2 parameters, x and y, both of which are integers. And it's going to return an integer, which is just int, not integer. And all I'm going to do is return x plus y. There. So now this function isn't called yet, hence my IDE helpfully grays it out to let me know that it's unused. But it's going to take 2 values, x and y. It's going to add them and return that value. Now I could have done this in 2 lines and said sum is assigned the value of x plus y, and then return sum instead. Or, and you may as well get used to this, there's multiple ways of doing things in certain parts of Go. I could declare a variable sum that's an int, and then make sum, I'm not creating and assigning the type here, this is the shorthand. I could just say sum equals x plus y, and that works. So all of those work. Of course, I like to be concise, so the way I'm actually going to do it is to return x plus y. Great. Now, you got to start thinking like a programmer. Are there any situations where this function might not work? What if I pass it x and y, but one of those is not an integer? Well, actually it wouldn't compile, but for the sake of argument, I probably want to say, don't just return an int type, return an integer, and if there's an error, return that, which means I'm returning 2 types. So here I can't do the shorthand of x plus y. I need to add them together. So I could say, if I was throwing an error, I would have to return my values. So I would declare a variable. I'm actually not going to do this because it's impossible to throw an error here easily. I could say var sum equals x plus y, and then return that and nil, because there's no error. But we actually don't have return sum and nil. And sum is an int. I think I need more caffeine. Anyway, that's what I would normally do. If I would check for an error, here I'm just adding two ints. I know they're going to be ints because it's a strongly typed language. I can't accept anything that's not an int, but I can return my value and an error if there isn't any. Of course, this is a really simple, straightforward function, so I'll just go return x plus y and make this return just an int. But we'll create a third page in a minute where it's more possible to have an error, okay? So now I've got this function. I actually want to return it. So let's go up here and call it. Let's say my sum, and here the scope of this sum is only within this variable. That's going to be equal to add values, and I'll pass it two integers, 2 and 2. And I can't just not use this variable. I've created it. So Go says, well, you've got that variable. I don't want variables hanging around that don't do anything. So if you're going to create it, you better use it. So let's change this. Instead of just returning a string here, let's cut that out of there and format sprintf. And now we're going to say, this is the about page, and 2 plus 2 is, and now I'm going to put in an int in there. And remember sprintf, which I better spell right, sprintf actually wants a placeholder, and the placeholder for an int is %d. If it was a string, it would be %s, but we'll learn more about that as we use it. Right now, I need to put an integer value in there, and I just calculated one, and my calculated integer is sum. So I can put that in there and write it out. And this throws an error, which I'm going to ignore right now, and remember the shorthand for ignoring something that's returned by a function is to use the underscore. So fprintf actually returns two things. Right, so I'll ignore both of them. So now I've created a home handler, I've created an about handler, and I have these which point to those functions. And this function about actually calls add values. Now here's another thing you have to get used to. When a function name, or a variable name, which we'll get to later on, begins with a capital letter, it means it's accessible outside a given package. It's not true for the main package because you can't call the main package from an external package, but you may as well get in the habit of doing things properly. I am never going to call this function from anywhere else, so I'm going to give it a lowercase name, and that hides it. If you come from an object-oriented background, if you've done some programming like in Java or even PHP for that matter, you can think of this as making the function private. The only places that this function can be called from are within this package. And the way that Go does it, if it has an uppercase letter for the first letter of the function name, then it's visible outside of the package. If it has a lowercase one, it is not. So I'm going to leave it like that right now. And we may as well get into the habit of giving comments to things as well, because they're quite helpful. A comment is something in a source file that is ignored by the compiler, and it's just there for people like you and me to read. And you can write a function with 2 slashes. And the convention in Go is that the very first thing that should appear in the comment above a function is the function name. About is the about page handler. And the same thing with home. Home is the home page handler. Now you don't have to give things comments, of course, but you probably should. Even though this one's not going to be visible outside of the package, I'm going to give it a comment. Add values adds 2 integers and returns the sum. And then main, I'll just call this, is the main application function. The entry point, in other words. Okay. So there we are. Now I've got this all built. Let's compile it and see what happens. So all I do is open my terminal and go run main.go. That's it. So it starts. It seems to be running. Nothing strange is happening, but I'm going to make it even simpler. I'm going to stop this and come down here, and just before I call my HTTP listen and serve, I'm going to write to the console. And I'm going to do that like this. I'm going to come to the top just after my import statements, and I'm going to say, well, the port is something I might want to change, and I might use it in more than one place. So rather than just putting port 8080 like this, I'm going to create a variable called port number. which doesn't exist yet. And I could declare it inside the main function if I wanted to, but I might want to use it in another function. So to do that, I'm going to change where I declare this variable. And I'm going to say var port number equals :8080. And now that I've done that, I can actually use that where I need to. So I've got my port number now, and I can use that down here, and I already have. So that's great. So the simple thing I can do here is say var port number. Now I can actually get better than that. I never want this port number to be changed by another part of the application. So I can say instead of var, which is a variable, which you can just overwrite it with a different string value, I can call it a constant. And the nice thing about a constant is it can't be changed by anything else in the application. So now that I have my port number specified, I can come down here and I want to write to the console. And I'm just going to say format print line. And then again, in here I want to use that port number, so I'm going to use format sprintf starting application on port, and this is a placeholder, but it's a string, and it's not an int, which is the only thing we've used so far. So %s is the placeholder. And now I need to say, what do I want to replace that placeholder with? I want to replace it with port number. All right, so let's run the application again. And now when I start it up, it's going to say starting application on port 8080. So let's go over to my web browser and refresh this page. And this is the home page. So when I get this is the home page up here, that's because I didn't specify anything after the URL. If I put a slash there, I should get the same thing. This is the home page. And down here, it says in these handlers, aha, if it has nothing or a slash, go to home. And the home function just says, this is the home page. Let's try the about page. So here, back in my web browser, /about. This is the about page, and 2 + 2 is 4. Exactly what I wanted. And what did it do? It said, well, when you made the request, it wasn't just slash, so I'm going to ignore that. And under here, we have /about, so now return whatever the about function gives us. And the about function calls this function, add values, adds 2 + 2, the parameters I specified here, stores that in the variable sum, which is an int because we use the shorthand assignment. This returns an int, therefore this is an int. And down here I just say print to the response writer W this computed statement. This is the, which I spelled wrong, so I may as well fix that. This is the about page, and 2 + 2 is %d, replace %d with sum, and 2 + 2 is 4. So there you go. Now, we can handle 2 pages. Of course, we can handle many pages, as many pages as we want to, but this is sufficient for our purposes for the moment. So let's stop now, and we'll pick it up in the next lecture.